So why don't you go ahead and introduce yourself?
My name is Roberto Sherbo. I'm a grad student at Virginia Tech, and my partner on this project was Felipe Basim, another grad student.
Tell me about this project that you were working on.
So this project is kind of a brainchild between Felipe and I. It's this idea that we wanted to bring real-world objects into a virtual space so that you can interact with them. It's like AR on steroids. What we did was mapped out this whole entire room, and then we had this game going on that you are launching Kiwis at Llamas.
So what motivated you to come up with that?
Angry Birds got really big at the time that we were doing this. And Kinect Fusion, which is a demo from Microsoft, came out at the same time. So what we kind of looked to do was see how we could bring this idea of Angry Birds and this awesome game mechanic, as well as what can we do with Kinect Fusion. And what made us tie this all together is this idea that we really wanted to bring out the normal everyday devices that we use. So we used an iPad, and we created this game where we have all these real-world obstacles as well as virtual obstacles. And you shoot little Kiwis at llamas and you get points, and it's meant to be really fun but allow you to interact with your real-world objects. Some of the really cool things that we did was that you could break virtual objects, but you could also break real-world objects. So we actually have this thing where we break into the table and see this room underneath, and we can also break into this box and you see the box, what was like this little dungeon inside of the box, or stone cave rather. And so this is kind of a neat idea and a new way of playing while still maintaining these core ideas that we had.
All right. So how did you take the idea for this game and turn it into a reality?
We use an open source version of Kinect Fusion called Kinfu by Point Cloud Libraries. And what that does is it leverages the depth sensor of the Kinect, and it models the entire world and creates a 3D mesh. And so what we did is we used this 3D mesh as the collision geometry as well as the occlusion geometry. We take this 3D mesh and we line it up with the real world objects. Now when we place a virtual object in the real world, it knows how much of it should be shown and how much of it should be hidden by the real world object. You also get this really neat effect when you shoot a Kiwi into the world of it will hit either the real world object or it hit the virtual object, because it knows where everything is in the real world. So this gives you a more realistic effect than your traditional AR games.
I see that the game uses a slingshot. Can you tell me a little bit more about that?
Yeah, so that adds into this effect of playing with real world objects. So we really wanted this visceral effect of pulling onto a slingshot to launch it, because that's what you're doing in Angry Birds. You are launching a bird into space. And rather than having to do that with touch, we really wanted to make it be a real world action. So what we've done is we used conductive rubber, and as you pull, it changes the resistance. And from that, we can determine the trajectory in which you're aiming the bird, as well as the force. And that kind of all plays into the game mechanics.
Why did you choose this approach?
We chose this approach because we wanted to showcase these mini computers that we carry around with us every day. The iPhone and the Android are so popular, and they have so much computing power. And as we see the new Nokia phones with the extremely high resolution pictures, or the Evo with its 3D picture taking capabilities, we can kind of see this technology move in this direction. PrimeSense, the company that makes the sensor for the Kinect, actually does most of its onboard processing in a very small chip and form factor. So we conceivably can do these type of things maybe in the next 5 years in our pockets. Higher resolution cameras are coming out in terms of depth sensing that also attribute to kind of be able to do this on the fly. So that's why we chose to do it in this way, is because we wanted to showcase the possibilities.
What can you see using this technology in the future?
This question gets me really excited because we feel like the possibilities are endless in terms of play. Anytime that you have static real-world content, you can now add a sense of motion to it. You can add a sense of excitement and adventure to it. For example, let's say you build a Lego fort. Now, we've all done this as kids, and you play around with it, and it's great, but what happens now if you bring out your iPad or your iPhone, and then you can see a person playing inside that fort? You can have a virtual dragon come and destroy your real-world fort, or you can play with different objects in terms of what's real and what's not real. Also now with the community that we have of modders and hackers and do-it-yourselfers, a lot of people are doing multiple things. They not only do just pure construction in terms of building really cool objects, they also do, computer programming or computer modeling and things like that. So you can kind of see people doing these things already merging these two areas together, and this is just a platform for doing that.